Okay, so it is May 11th. Place. May 11th. It is the last day of notes. And this is section 5.9. More integration with inverse trig. And it's day 2. I think I want to start with that problem I told you to leave off the homework. Let's see how to actually do something like that. And then you'll try that homework problem as our second example. So in the homework, it was a definite integral. I'm just going to do a regular antiderivative, not a definite integral thing. But I want to integrate the arctangent of x over 1 plus x squared dx. And you can't see it. Where is it? Okay, that's a little bit. The integral of the arctangent of x over 1 plus x squared dx. What is the integral of the arctangent of x? Can you find it in your notes? The integral of the arctangent of x. Did I teach you what the integral of the arctangent of x is? Can you find it anywhere? Or do you not know it? Those are the two options. Do you know it or do you not know it? Michael? Do you know the integral of the arctangent of x? Or did I not teach that to you? I don't think I gave you formulas for integrating those things. But we can still deal with this problem somehow. Any ideas? It's actually a good thing that those other random things are there. What's our usual trick when we deal with integrals? Say a letter of the alphabet. There we go. If we try to use substitution, what would happen if I made u the arctangent of x? Do you know the derivative of the arctangent of x? I really hope you do, because I think we just took a quiz on that today. Why do I feel like this is really, really good? Well, not even really on the bottom. You have 1 plus x squared on the bottom, so don't you have, like in general in the problem, 1 over 1 plus x squared, which is what I want for my du. This problem is just integrating u du. You can handle that. This is like earlier in the year when I asked you to do an integral that had a natural log in it. I never taught you the formula for the integral of the natural log of x. But we could make that our u, and its derivative showed up in the problem, so we could work with that. This is the exact same idea. Well, what's the integral of u du? This is easy. U squared over 2 plus a constant. U was just the arctangent of x, so I'm just going to say the arctangent of x squared over u plus the constant. The only reason you were able to do this problem is because I made that denominator that 1 plus x squared thing. If the denominator was something else, you wouldn't be able to handle this. But because the denominator was the derivative of the thing that I gave you, we can work with it. So let's go back to the homework problem that I told you to skip. Number 19 from the homework. It was a definite integral, but I think we can handle it in a similar way. So how about you ignore the fact that it's a definite integral? deal with your u substitution things, and then stop. Then we'll go back to the whole definite integral part. We'll change the limits and all that stuff. But I think it's going to work in a very similar way to the problem above it. And I also think in like a minute or two, I'm going to repeat everything I just said because I think it's about that time for the world history people to join us. I can promise you there will be one like this on the quiz. I'm not sure if it's an antiderivative or a definite integral, but you will have to deal with integrating something with a trig function in it, an inverse trig function in it, whose derivative is also showing up. I think u is easy. What's u? Arc sine of x, which is nice because its derivative, 1 over the square root of 1 minus x squared dx, exactly what you have. This really just becomes the same as last time, the integral of u du. What's the extra piece that we have to deal with? Okay. So when x is 0, u is going to be the arc sine of 0. When x is root 2 over 2, u is going to equal the arc sine of root 2 over 2. Pi over 4. When angle is the sine of root 2 over 2, pi over 4. We're going to integrate u du from 0 to pi over 4. Do it. Find the antiderivative, plug in. The answer will look a little weird. There may be pi's or other things like that in the answer. Integrate and let's see what happens. Pi squared over 32. The whole point of what I just did was I found the area under this strange looking function that has an arc sine and a square root in there, starting from 0, ending at root 2 over 2. My area, signed area under this thing, ended up being pi squared over 32. Do you see how to deal with that? There'll be another one tonight. Definitely one in the quiz. Don't know if it's an antiderivative or a definite integral, but there will be something like that. We'll give them one more moment to come on in. Welcome back. Sorry, but I don't want you to miss the last day of calc. I'll go back through the two things we just did in a little bit. Welcome back. I won't make you write any essays. Hope it wasn't too bad. It's over. It's over. So, I'll go back to the first examples a little bit later. They were like that problem 19 from the homework that I told you to skip. We'll go through how to do those. I don't think it was a big deal. If you have homework, I can check that a little bit later, but let's just kind of keep going with this stuff. We'll also go through the homework later for those of you who are just getting here. Welcome back. We just doubled the size of our class. Okay. More integrals with inverse trig. Here. Okay. So our formulas are on the side. We'll kind of keep referring to those. I would like to figure out the integral of dx over x squared minus 4x plus 20. First thing I'm going to tell you is, yes, this does have something to do with inverse trig. If you had to take a random guess, hopefully not totally random, but a random guess about which inverse trig function it might be involved with, what might you possibly think? I realize nothing's perfect, but if you had to guess one? Tangent, because there's no square root. I also see like an x squared, a constant squared. I think you'd actually be perfectly fine with this if it just wasn't for the 4x in the bottom. It wouldn't be like, nice, our constant we're squaring would be the square root of 20, but you'd be okay if there wasn't the 4x there, right? I want to take a moment and go back to something from the homework. There was a question that nobody asked about from the homework that I just want to make sure you got. We'll come back to this in a moment. But I want to take a look at, in your homework, number 9 from the homework. I noticed nobody asked about this one. 1 over the square root of 1 minus x plus 1 squared dx. Did you not ask about this because you knew what to do? What would you do? Use what? And then it's exactly in our form for arcsine, right? This shouldn't have been a hard problem in the homework. However, what if instead of giving you the problem written like this, I actually did some like expanding in the denominator? Let's say I gave you 1 over the square root of 1 minus, that's x squared plus 2x plus 1 dx. That is the integral of 1 over the square root of 1 minus x squared minus 2x minus 1 dx. Would you agree from the algebra that this is like the exact same thing as this? Do you know what to do here? Do you know what to do for this part? If I just gave you this problem, would you know what to do? If I just gave you this inside integrate, I'm kind of expecting the answer, probably not. But if we were able to write it in this form, you'd be good. Our goal with problems like the one I gave you for the example and other things is to do some algebra to let us write it in a good form so I can just do a use substitution and go from there. We're going to have to do some factoring. Not just factoring, though. A special type of factoring that you talked about in Algebra 2 and Pre-Calc called something the something. What am I talking about? We need to review some completing the square. I promise this is not going to be terrible. D Block groaned as well, and when we got through this, they realized this is actually like really not a big deal. So it's not going to be a big deal. I want to go back to that problem I gave you. If I could do some factoring to rewrite this thing, I could handle this. Here's how completing the square works. First, I'm going to sort of separate things in the denominator a little bit, just kind of move things, group things a little differently. I'm going to get dx over x squared minus 4x plus 20. I didn't do anything but add in some parentheses there. That's all. My goal is to turn the parentheses into what we call a perfect square trinomial. There's a formula to figure out what number I can add in here. The formula says all I need to do is take my middle number, do half the middle number, and square it. And I really hope that sounds a little bit familiar. I'm going to do half that middle number and square it. Half of negative 4 is negative 2. Squared gives you what? I'm going to add a 4 into the denominator. Can I just do that? Is this the exact same thing as this problem? Take away the parentheses, combine like terms. Is this the same thing as no, it's not. You can't just add a 4 into the denominator. But if I add in a 4 and then cancel it out by subtracting a 4, that would be okay. Would you agree if I took the parentheses away here and combined like terms, I would get the original problem? Does that seem reasonable? I'm going to do some factoring. I need to factor that x squared minus 4x plus 4 thing. It's a perfect squared trinomial. We could think about multiply to 4, add to negative 4. Or we could use a shortcut formula for factoring these things and realize it's going to be x and then half the middle number before we do any squaring. Half of negative 4 was negative 2. And I can say this. If you don't believe me, FOIL x minus 2, add 16. Yeah, you'll get the original thing back. Do you think you could integrate this thing? Do you know how to integrate this? What letter should you be saying? Do a U substitution. Do you see now it's basically in our arctan form? Go integrate. What was that? Say that again? Weren't we going to do that like after class so you don't miss more new stuff? We'll do it. Let's try it maybe then. But I don't want you missing new stuff. Emily, what's you? Of course, it's the variable thing that we're squaring. Du? 1 dx. We can write this problem as the integral of du over u squared plus 16. Do I get a 1/4 out front? Do I have a 1 over a out front before my arctan form? Okay, so I should have a 1/4. Then an arctan of u over 4 plus a constant. And we'll just finish by saying 1/4 times the arctangent of x minus 2 over 4 plus a constant at the end. These are all going to work in this way. We're going to do some completing the square, although each form has slight little differences that we'll have to deal with. We'll see how it works, but it's the same basic idea. We'll add half the middle number squared, balance it out somehow. We'll do some factoring, use substitution, and we'll integrate. Questions on what I did in that first problem? Okay, let's take a look at another one. Let's take a look at, let's do the integral of dx over the square root of 8x minus x squared plus 9. And the first thing I want you to do is ask yourself if you had to guess an inverse trig form, which might it be? Chrissy thinks arc sine. I just saw some nodding. Okay, what's telling you arc sine? Well, but there isn't an absolute value of x in any...
Oh, I mean there's no x out in front.
Ah.
And there's no, and then there is...
There is a square root. There's nothing before the square root. Also, the x squared, was it positive or negative, the x squared? And don't we have like a negative variable squared thing in the arc sine case? I'm thinking arc sine. There's something about the denominator I just don't like. Well, yeah, but other things, well, yes, the 8x, but do you like the order? Let's change the order. Let's write this as the integral of dx over the square root of negative x squared plus 8x plus 9. Completing the square only works if the number out front is positive 1. That is not the number we have up front before the x squared. We have a negative 1 up front. What I'm going to do is I'm going to factor a negative 1 out of the pieces that have an x in them. I'm going to leave that 9 alone. I'm going to say negative 1 times x squared minus 8x with that plus 9 at the end. I need to figure out a number that I can add in here to complete the square. How would I figure out that number? What did we do in the tangent problem? It's going to be the same idea. Where's that coming from? Half the middle term squared, that's negative 4 squared, that's 16. I'm not going to subtract 16 on the other side. This 16. By adding in a 16 here, did you actually change the denominator by 16, or did you actually change it by some other number? What am I talking about? Because of that negative out front, by adding this 16 here, didn't we actually change the denominator by a negative 16? How would you balance that out? A plus 16. That's the difference with the arc sign problems. We've got that negative 1 factored out, so if I add in a 16, it's like I'm actually changing it by negative 16. So I'll balance it out by adding in a 16 at the end. We can now do some factoring. X squared minus 8x plus 16, that becomes what piece in parentheses squared? X minus 4. X and then half your middle number. Half negative 8 is negative 4. And I feel like I'd rather change the order again. So let me make this dx over the square root of 16 minus x minus 4 in parentheses squared. You can finish this. Gosh. Okay, so we're going to change that. We're going to use the right number there. Thank you. Say that sooner next time. Now maybe you can deal with that. And how would you deal with that? Do it. Does arcsine have a 1 over a up front? Okay, so forget that. Let's do the arcsine of u over 5 plus a constant. So I'm thinking arcsine of x minus 4 over 5 plus a constant. Same idea as arctangent. It's just we have that negative 1 thing where you factored out that we have to deal with. I actually think that of the 3 forms, this is probably the toughest one with the completing the square. We'll do another one of these at the end of the period. Questions or issues on this? Next one. You know what form this one has to be. Which form is this one going to have to be, given how we do things in here? Probably have to be an arcsecant one. Let's see. Let's do dx over x minus 2 times the square root of x squared minus 4x plus 3. obviously it's arcsecant because we haven't done an arcsecant one yet, but what in the problem might make us think arcsecant things? How do you know it's not arctangent? That's an easy one, I think. There's a square root. Why arcsecant rather than arcsine? Yeah, there's that thing out front that makes me think maybe arcsecant. I don't totally know how that thing out front is going to factor into things. What I would like you to do is take the thing underneath the root, complete the square on that. There's no fancy like -1 thing we have to do like we did with the sign. You're just going to separate the x squared and the 4x from the 3, complete the square, balance things out, and if we do it properly, things should actually work out very nicely with other pieces that we have in the problem. Caitlin Carson, what are you going to add inside the parentheses to complete the square? And add another 4 or subtract a 4 on the outside? Subtract. This truly is a positive 4, so yeah, we are going to subtract 4. And this is going to give us dx over x minus 2 times the square root of Caitlin Arsenault. How are you going to factor that thing? Why do I feel like this is really, really good? What worked out really nicely here? You've got the exact same thing out front as inside. If that doesn't happen, either I wrote the problem wrong and it didn't work, or you messed up somewhere in the work. For us to be able to get arcsecant, you will get the exact same thing over here that you have over there. That's not too bad. Go do your u substitution, and let's integrate this one. Then we'll do a definite integral, and then we'll be set. Although I may go back and do the 2 examples people who were out missed.
How many of the steps is it in that first?
A couple completing the square, maybe 3 or so. Probably 1 of each type, and a definite integral. Tonight's homework, half of tonight's homework will be review of the stuff you were doing last time, just regular u substitution things. The other half will involve us completing the square. I don't think this is too terrible, though. I don't know. U is x minus 2. du is dx du over u times the square root of u squared minus 1. 1 over 1, I guess that doesn't matter. Arcsecant, absolute value of u over 1. And we'll get something like that. I want to do one definite integral. And I think we'll do that with an arcsine thing because that completing the square is a little more involved than the other 2 types. And then we should be good. Let me find another sheet. So we are going to take a look. Move this up a little bit. Put this over here. We're going to take a look at the integral from -2 to 2 of dx over the square root of 28 minus 12x minus x squared. What I would like you to do is ignore the fact that it's a definite integral. We'll deal with that later. I want you to go deal with your completing the square. And you may want to go back and look at your notes for how we dealt with the other arcsine problem where we factored out the -1. Just complete the square and stop. Don't actually finish off with the u substitution and that stuff. When you factor out the negative, is it coming out of all three pieces? Yes? No? Factor -1 out of all three of those things? No? Okay, so why not? Which one are we not going to factor the -1 out of? 28. Just going to leave that over there. Oh, okay. Sydney, what's going to get added into the parentheses? Half the middle number, half of 12 is 6. Square it, you got 36. Perfect. You need to write it out. Half of 12 is 6. Squared is 36. Add 36 or subtract 36 on the outside. Why? Because this 36 is actually changing the bottom by -36, so I'm going to add 36. The integral from -2 to 2 dx over the square root of, I'm going to switch the order around a little bit and say 64 minus, Michael, what does that thing factor into? The x squared plus 12x plus 36 thing. Okay, so when we're factoring, it's going to be x, and then the number part is just half the middle number. So what's half your middle number?
6.
It's going to factor into x plus 6 in parentheses squared. If you FOIL that out, x squared plus 6x plus 6x plus 36, yeah, we've got the x squared plus 12x plus 36 that we want. You need to do a use substitution. What's the extra piece we have to deal with, though, in this problem because it's a definite integral? Do that, please. See if you can finish this one off. While you're doing this, I'll pass out the homework. Those of you who weren't here when I checked homework, you can show me the homework or we can take care of that on Monday. Your call. And I think since we are running out of time, what we did at the beginning of the period was talk about problems like 19 from the homework that we didn't have time to get to yesterday that I told you not to worry about. That's on the video. That's like the first 5 minutes of the video. I will post this on the website. Take a look at that. There will be one of those on the quiz on Monday. Watch 5 minutes. You don't have to watch the end of the video. That's completing the square stuff. But watch the beginning. You'll get that stuff. It wasn't hard. You just need to see how to do it. Also for homework, please do the extra credit. Not the 3 people in this class who have already done it. But please, please do this. We need 12 people between my 2 classes, 12 out of 40. Or we get the boring version of the extra credit review. Not extra credit review, final exam review. Let's not do the boring version. Okay, u is x plus 6. du is dx. When x is -2, what does u become? 4. When x is positive 2, what does u become? I want to integrate from 4 to 8 du over the square root of 64 minus u squared. I'm going to get the arc sine of u over 8 from 4 to 8. I'm going to get the arc sine of 8 over 8 minus the arc sine of 4 over 8. I'm going to move up. I'm going to get the arc sine of 1 minus the arc sine of a half. Those are all good numbers. Arc sine of 1. What angle has a sine of 1? We're really packed up already? Cosine of 1. Michael, the arc sine of 1/2.
Pi of 6.
pi over 6. I'll get a common denominator. I'll do 3 pi over 6 minus pi over 6, 2 pi over 6, pi over 3. And we are done. I'm sorry we had to do stuff today, but today is truly the last day that I have to like teach you guys to get a quiz in and get the review in and do last day things. So I apologize to those of you who just took an exam and then came and did math. But now we're done. Well, sort of. Let me shut this off because it's still recording.